Hello, everyone, and welcome to our webinar, Database Administrators Did You Know? My name is Jessica Malakian, and I'll be today's moderator. So let's start by quickly introducing today's speaker. For today's webinar, we have Marie Candela from the OpenEdge Product Management Team. Marie is currently a member of the OpenEdge Product Management Team, providing a focus on data management. Marie joined Progress in 2006 to be the development manager for the OpenEdge database, a role she enjoyed for several years. Moving from development to release management to product management, Marie now gathers customer requirements, defines features and capabilities, and drives their rollout and delivery in releases. And now I'll turn it over to Marie to start the presentation.
Thank you, Jess. And thank you, everybody, for joining me for the Database Administrator's presentation for OpenEdge 12.8. As 12.8 is a long-term support release, or an LTS, I'll also be including features that had their first introduction in innovation releases along the way to 12.8. This presentation is basically buffet style. We will just sample a number of things from different areas, and we'll look at some of our areas of focus on the way to OpenEdge 12.8 and enhancements in those areas. Many of the enhancements that we added in the database in releases of 12.3 to 12.8 are to give you ways to manage space and time. First, we're going to take a look at backup and restore. Database backup and restore are critical parts of an organization's operational and risk management strategies. Our enhancement goals with backup and restore generally fall into two areas: minimize the recovery time objective for the disaster recovery scenario, and to minimize the offline period for planned and unplanned outages. We have added several pieces of functionality that you can use to reduce both the size of your backups and the time it takes to back up and to restore. The first enhancement is to make it easier for you to couple the backup file and the OpenEdge version together. This could be that you have a backup file and you're not sure which release it came from, so that you're frozen from it restoring it. Or the other is that you have the specific release and you're looking for the backup file that matches it. This one originated in one of our online communities when a customer said, anything that gives someone the ability to see what the version is that backed the file up, especially if ProRestore can't restore it. We had this issue attempting to restore a V9 file backup and had to poke around with installs, trying to figure out which one might do it. Our existing option at the time was, well, we were relying on you and your storage strategy. And so we've created a solution here so that we can help you do that. We've added an option to ProRestore, the -describe option, which lists basic information about a database backup file to help you identify which backup you want. It works for both full and incremental backups, and it's compatible from version 9 onwards. Here's the output. That's an example for a full backup. Notice that it's telling you date and time. It gives you the database name. It's also helpful with giving you the minimum OpenEdge version that you'll be able to restore this backup with. It identifies platform, if it was online, incremental, your compression level, etc. Okay, next we're going to move to compression of the backup file. Again, this was started with another complaint in an online community where the customer was saying, we now have to go to using third-party software to compress the database backup file. First, we have to wait until the backup is completed, so the backup file is already using disk space. After completion, we start the compression, which also takes time and disk space. It would be nice if ProBackup could really compress the backup data immediately. This would save both time and disk space. The issue here was that the current RLE compression algorithm is rather basic and efficient. So what we've done for this is we've added another option for compression. We use a third-party Z standard compression algorithm. We've added two new options on Pro Backup to help manage this, dash COM for compression, off or on, and dash COM level to indicate which level of compression you're going to use. Z Standard, as you can see on the right part of the slide, actually offers 3 different levels, which lets you manage if you want the fastest, which will also be the least amount of compression, or up to the slowest, which will be the highest level of compression. This works on online and offline backups. And starting with OpenEdge 12.5, we changed our default to use Z Standard instead of RLE. It's still available if you want it. You have the ability to specify which compression level so that you can balance speed and space. And what we were very interested to learn about this is not only did it improve performance for Pro Backup, it also improved performance for Pro Restore. That was a surprise and a good one. Next, we'll look at the issue of what everybody wants. Please make my backup go faster. Backup is a CPU-intensive operation, and our analysis shows that the operation can spend 90% of its time in checksum and compression tasks. So what we've done for this, if we've implemented threading as part of the backup operation. The database stays online, so this is specifically for online backup. Users stay connected. We still have the constraints with the online transaction processing limitations. There's that BI pause, though we reduced that significantly a few versions ago. It is still present. And also when we're running into schema or user area backup, any updates to the DB blocks there must wait while a block is being backed up. This is because we need to ensure database integrity. So there were options added for you to be able to adjust your system resource usage with the online backup with threading. First is you enable or disable multi-threading, and then you can specify the number of worker threads. Those worker threads are doing the reads from the database and also the compression activity. The more of those you have going in parallel, of course, the better throughput you're going to have on your backup. We also, at the other end of the backup operation, where we're writing out the information to the backup file, you can specify the number of writer threads that will help you move those cached database block write buffers to disk. Okay, so we took care of threading for online backup. What about restore? ProRest is a single-threaded sequential restore of database blocks. Similar to backup, it spends significant time doing disk I/O, reading the backup data from the backup file, and also writing the database blocks to the restored database. It also spends a very large amount of time decompressing the compressed backup blocks. It performs a CRC check to verify that there are no corruptions in the database blocks in the backup file. So likewise, we did incorporate threading into online restore. This threading can restore full and incremental backups. It will cache the read and write buffers, so that's the front end and the back end of the operation, to minimize disk I/O contention and improve concurrency. In parallel, it can do the CRC checks, it can do the buffer transfer operations, it can do the decompression, and we also manage the asynchronous disk I/O. We have similar options here on Restore that we had to backup for adjusting your system resource usage. First, you enable or disable it. You can specify the number of worker threads, and then you can also manage the I/O at both ends, where you can have the number of cached backup block read buffers, and you can also specify the number of cached database block write buffers. So this has introduced threading into both the backup and the restore operations for online of those operations. But the restore process in general actually can have more to it. and we're looking for how do we put more parallel activity in that. As I mentioned earlier, Restore spends a significant percent of its time verifying the database integrity, and it is done as part of Restore using the cyclic redundancy check, the CRC. Now, if we could only separate that out, well, we did. We've created this no verify option on Restore, where it essentially bypasses that CRC check. Now, if you're like me, I'm going, oof, we're not doing integrity checks here. That makes me a little nervous. But we have a recommendation on how you can incorporate that into your process basically in parallel. ProRestore has for quite some time offered this partial verify option. What it does is it specifies that Restore will read the backup file and compute and compare the backup block CRCs with those that are embedded in the block headers. When you use the -VP partial verify, ProRestore does not actually restore the database. It's just doing that integrity check. So the proposed solution to being able to do your restores faster is that when you produce that backup file, you do a second step of doing the restore -VP to do the scan to confirm the integrity of the database blocks written in that file. What that does is basically what you've got is your backup on the shelf that's already been verified. And so when you go to do the restore, you don't have to do it again. I do want to warn you that if the partial verify does detect a CRC match, do not restore that database with no verify, because then you're going to be restoring corruption into that database. Okay, now we're going to move to space management. We have two drivers in our focus on space management. One is that we're quite aware of customers that are moving their operations to the cloud. And part of the benefit of being on the cloud is that you have different rates for different storage there. And you also need to optimize your storage by archiving older, historical, and no longer changing data to be able to take advantage of those different rates. You also have the need to be able to do these maintenance operations under space management without taking a database outage. First, we'll look at record fragmentation. The context for this is that when those tables are created, they're created in pristine and orderly manner. All the records are contained within their blocks. Over time, as you're using the tables in your database, we're going to create record fragmentation. It's just part of the operations. Records can become fragmented in two different ways. One is they split over multiple blocks. Another is that they become scattered and out of order. And when they are out of order, that's then going to impact your sequential access that the application is using. We have existing options to dealing with fragmentation. The first is to restrict access to the table and indexes and do a dump and load. That's an offline operation. The second is to use a table move utility. When you move that table, it's now rebuilding it and back into its neat and orderly manner. But when you do that, that doubles your disk space use. So that's sort of contrary to making it easier for you to manage space. So the problem we wanted to solve was how do we reorganize table data according to a specific index, but keep that database online so it doesn't affect your OLTP operations. Our solution for that is a new utility called Table Reorg. It only works on type 2 storage areas, and it allows you to specify the index that you want to sort on for rewriting your table. It will default to the primary index if you don't specify one. What this does for you is your scatter factor is now reduced, and it no longer indicates a need for a dump and a reload. And what we've done is during the table reorg operation, the space is reused as each cluster becomes empty. So We've just used a very small additional amount of space over time instead of doubling the size of the table reserved space. So the outcome of this new utility is that you can improve application performance when doing your sequential scan operations for both queries and table scans, and it also avoids database downtime while you're working to improve performance. The basic table reorg utility works pretty efficiently when you're reorganizing small tables, but for very large tables, table reorg can take a long time and generate a lot of recovery data while it's scanning and reorganizing the entire table. So we took on the need to optimize the utility to perform more efficiently for large tables. We have three options that provide flexibility for you to do that. The first is a cancel and resume support. What that means, if I started my table reorg operation and it's underway, and I decide I need to interrupt it to do something else. So when I cancel that operation in progress, it will leave a marker to show how far we've proceeded. And then we can restart it with resume on the command line. And that'll request that the canceled table reorg will resume where it left off. And it's not really exactly where it left off. Basically, it's going to back up to the first block of the current cluster that it left off in. The next option is restrict. What that does is it lets you reorganize sections of a table instead of the entire table. So you know in advance that you only want to do a partial amount. And you can use parameters on the command line to indicate the starting and ending positions within the table and manage how much of that table is scanned. If you omit the restrict option, it's going to reorganize the entire table. Our third option is smarter scanning. Smart scanning is the ability to skip reorganization of records that are already in order. There's no need to reorder them. They're already the way they would be coming out. And that's in the order of the specified index. Smarter scanning will scan until an out of order record is encountered. And it starts the reorganization process again at the first block in the cluster where the violation occurred. Okay, now we're going to move to table truncation. Table truncation has to do with how do I quickly clear out the contents of this table. The background on this is that generally, as time goes by, customers will find that some of their data is obsolete. They no longer have use for it. That could be because it's historical, could be that it's from OpenEdge operations such as CDC, change data capture, or it could be key event data that OpenEdge is tracking. Could be because your existing application no longer uses a table and you want to move the data out of a storage area because leaving unused data contributes to your storage costs and processing overhead. Again, there's existing options on Truncate Table. You can do a table drop, which uses an exclusive or DB access level lock, and it also invalidates the R code. So that's a drawback. You could do record delete by the client. Now that, because it's processing a record at a time, that scales linearly, which will eventually impact your application performance due to the level of concurrency of the record delete going on with your OLTP also going on. And by the way, it doesn't return the storage to the area. So the problem we want to solve is how do we quickly and efficiently delete a table's data and keep the database online without affecting the OLTP operations. We have solved that by creating an online table move with a truncate option. It allows you to either truncate your table in place, leave your storage in the same storage area, or you can truncate the table and move it to a different storage area. You would do that for an archive operation, perhaps. This is the closest thing to being able to do a drop table online without affecting either the R code or the CRCs. This command makes its storage space that was previously reserved to the area available for reuse in that area. It can be run online with active applications currently running. The tables and lobs must be in Type 2 storage areas. Along the way, it also does not excessively grow the BI file. It is very quick because it is done at the cluster chain level, and it will scale flat, which means that just because it's a larger table, it doesn't necessarily take longer to operate. It's recoverable, and another good thing is that the changes are propagated to the replication targets. The outcome here is that the DBAs will be able to remove database objects, the table, indexes, and lobs, remove their content quickly, and return the storage to the storage area for reuse by other objects. And this also, because it's an online operation, avoids database downtime when you're trying to improve performance. Now, I mentioned the other two options to this, and what I've done is created a table here to compare the techniques. You can see that they each have yeses and nos in the different rows. I'm not going to go through all the detail in this slide. I've supplied it basically as a reference for you. But what you would do is look at the different line items and determine which one is most important to you and which option is best matched to your needs. Okay, next we're going to look at online area truncation. The background for area truncate is that it's been an offline operation. It's a hefty one. It requires the AI to be disabled and it truncates the BI. Because you're truncating that BI, it's forcing it replication targets to be rebased. So the problem we want to solve is basically make this existing area truncate operation, make it an online operation with none of those constraints. And again, this contributes to you avoiding having to take the database down for storage area management. Our solution was to enhance the existing ProUtil truncate area command to work online. And we did just that. It works online, it works with after imaging enabled, it works with replication, it works with type 1 and type 2 areas, it works with pub and non-pub tables. The outcome of this command is that the schema is preserved, the area high water mark is reduced, all object chains are reset, so there's no RM chain or index delete chain affecting the truncated object. It does, however, have the prerequisite that the area needs to be empty of objects, which we just did with the previous command. After online area truncation, we move to online area removal. The history on this is that the ProStruct remove utility, which is what you use to remove extents from the storage area, and when all extents are removed from the storage area, it will then remove the storage area. That utility has only been available when the database is offline. Again, you require a maintenance outage to use it. So our solution was to take the existing ProStruct remove command and make its online counterpart, ProStruct remove online. This also works with replication, works with type 1 and type 2 areas. It is only able to be used for data storage areas. So for example, not schema. It is for fixed and variable extent types. Its prerequisite is the previous command. The area must be empty of storage objects and truncated. This contributes to the outcome of avoiding costly database downtime for storage area management. And it also enables customers to reduce your space footprint dynamically without waiting for a scheduled maintenance window. So you can be more responsive in the cloud to your storage needs. This completes our three-step process to fulfill our mission to return database storage to the operating system while the database is online. I have a demo here that development produced that I would like to share with you to see how this process is exercised.
OpenEdge allows you to return the unused space to the operating system even when the database is running. Let's take a look at the process of returning the storage space to the operating system online, followed by a demonstration of how to remove a data storage area while the database is running. Database administrators often encounter situations where the business no longer uses the historical or processed data. The storage space remains allocated to the database even after archiving the data. Depending on how the storage is used, there may be costs associated with it. OpenEdge allows you to return unused space while the database is running, which eliminates the need for downtime. The first step is to truncate table data online to give the space back to the storage area. Run the ProUtil table move truncate command to truncate and move the table data and regain the space in the storage area efficiently and quickly without having to recreate the schema. After moving the objects out of the storage area, the next step is to return the storage space to the operating system without any disruption. Run the prostruct remove online command when the database is still running and return the storage space to the operating system without scheduling a production outage. In the following demonstration, you will learn how to remove a data storage area while the database is running.
Today, I will be giving a demonstration of prostruct remove online. It is the online version of prostruct remove. So the first thing I've done is I've run a script to prepare the demo environment. I've created my databases using sports as the template. I have enabled replication, started the databases. I added some areas, and I added a table to one of those new areas. First thing we're gonna do is make sure everything's okay by using ProUtil describe. So the bottom terminal is my target, making sure it's configured as a replication target. Top terminal is my source, making sure it's a replication source. So everything looks good. Going to list the areas for the source database and also for the target. So the source database and the target database, so they don't match physically. For the new table area, there's 4 extents on the source, and on the target, there's only 2. That's okay because we only care about the same areas. We don't care about the physical layouts of the extents. And just to show that in the source database, using DB analysis on one area, the new table area, there is a table in this area. And now what I want to do is I want to remove an extent and then eventually the area from that new area. So the way to do that is to use remove online. And there's a restriction that we can't do this if there are objects in the area. You have to get those objects out of the area first. So one way to do that is to use table move. So if this was a very large table, what you could do is you could purge the records first, delete all of them. That would take some time, but it would be online. And then you could move the table afterwards to somewhere else. So for now, for this demo, I'm just going to move it directly using table move. And table move completed, and I should be able to remove it. Yeah. So prostruct move online. What you notice is that the syntax is the same. It's prostruct, then remove online instead of remove, then the database name, D for data area, and then the area name. There's a lot more output. Just like add online and increase to, remove online has to do this wait, where it's telling the database I'm about to do something. All these users have to respond to it before I can continue. And the reason for this is that, one, we're going to be deleting files, so we need to make sure everybody closes the files, otherwise the space isn't actually returned to the operating system. But also every process in the database connected, they have their own internal bookkeeping of how they open the files, and we need to make sure that everybody's in sync with that. So once we recheck, very likely this will be done. If you have DB notify time set to non-zero, this is typically almost always going to complete quickly. If you're using user notify time 0, DB notify time 0, you may have to disconnect some language clients. But even then, it depends on what those clients are doing. If they're idle and connected to other databases, then they may need to be disconnected from this one. Okay, so remove online finished waiting, and it deleted the area extent record for area 22, extent number 4. So if I list the files for this, we have 3. So 3 extents remain on disk. And if I check what ProStruct list displays, then we see that there are only 3 extents. Now, this is something important to note. Just like the offline version of ProStruct remove, when we remove the final extent, we do not change the type of the preceding extent. So we removed extent 4, extent 3 is still fixed. We didn't make it a variable extent. So what did this do to our replication target? So I started ~f on the database, on the replication target database, and there's nothing from the agent. So there's no impact to the agent for removing a single extent like this. So now what I want to do is I want to see what happens if I remove all the extents for the area, or if I remove the last extent. So I could run ProStruct remove online multiple times, or I can run it once, passing -all extents. So after because we're removing the area, and AI is enabled, we get this additional prompt. It's telling us that we can't just remove this on the replication target ahead of time. We can't just remove it on the hot standby ahead of time. What's happening is it's saying roll forward will automatically remove the storage area when processing the AI extent. The replication agent, when it sees this AI extent, is going to stop processing until you run remove online on the target database. Do I want to continue? Yes. And then we get to the usual remove online output. Again, we end up in this wait because we're removing files. We need everybody to handle their file handles and bookkeeping. And do I wish to recheck? Yes. So now it removed 3 area extent records, 1 for each of the extents remaining in the area. It removed the area record, and then we do an AI extent switch so that before the switch, any notes for area 22 are for the old area 22. If a new area 22 is added, so a new area added to the database with area number 22, it would be in a separate AI extent, so there's no confusion. And the files are removed on disk. So if I check, there are no files source_22, so no extents for area 22 in the source. And if we look at the bottom terminal, the replication agent saying that area 22 must be removed from this database. And the replication agent will will go into a wait until it's removed. And logins will be limited, so activity is going to come to a stop for application. So I'll leave that running. So what we need to do now is move on the target. So we could remove 1 at a time. There's only 2 extents, or we could just do the same thing and remove all because we're removing the entire area. So I'm going to do remove online -all extents. So ProStruct remove online got in. We end up at this familiar wait again. And we wish to recheck yes. And we have deleted the area extent records. We deleted the area record, and the files on disk. So the files on disk are gone for the target database, and I check first check list. The area is gone. So if we looked at the target database log file, replication agent detected that area 22 was removed from the database, and then default logins were enabled, so replication can continue again. So now, what about the hot standby? So what happens if we apply the AI extents to the target, or to the hot standby? So first, we need to figure out which AI extents to apply. So using AA image list on the source database, we see that the first extent's full, second extent is locked, third extent is busy, so we want to apply A1 and A2. Do that in the bottom terminal. So let's take a look at what we have for the standby database first. We still have the new table area, and it still has 2 extents. So let's apply the first after image file. This one is just one note because this was just before I did online backup. And now let's apply the second one. The second one should have the ProStruct move online operation. Okay, so we finished applying the second one. We check ProStruct lists. We see that the area is gone. If we check the database log file, we'll see messages. That these files were removed. There are additional messages up above that it started removing each area extent record, then the area record. And that concludes my demo. So what we showed was how Remove Online works on the source database and the impact to the replication target and also to hot standby. And that is all.
There, we're back. I hope you found that demonstration useful. So now we return to space management, but now we're going to look at your before imaging file, your BI. The thing is with BI is that there's opportunities for it to grow unexpectedly. The BI, what it does is it's a journal of your database activities. It's a critical piece for basic database functionalities. But if some unexpected things occur, it can become a huge performance bottleneck. The problem that we'd want to solve is that a user or application mistake can lead to unexpected and expensive BI file growth. Long-running idle transactions exacerbate this problem, and there's no other way to reduce the BI on a replication target database. The existing option has been to shut down the database and truncate the BI on the source. If you look at our picture on the right, this circle is basically representing your BI file. The open transactions in red, they typically have there's a transaction life cycle where they're opened, they proceed, we track what's going on in the transaction through the BI, and we close and we write them. But sometimes something that may be poorly written can sit there idle. Like maybe the user goes to lunch when they're partway through their transaction, and it just sits there holding that space, the red. In the meantime, other transactions that have since come and committed, they're waiting to be written out. And so they're just sitting there backing up. Eventually, you exhaust your BI space and you'll have an allocation of an additional file capacity. You'll have newly added BI file space. And this is how it starts to grow unexpectedly. Our solution for this was to create a separate process that scans your BI file clusters for those that are committed, the green ones, and see what's there to be recyclable so that we can reuse and reduce or eliminate the unexpected BI file growth. The name of this process is ProBIM for BI Before Image Manager process, and it comes along with a startup parameter to tune it, -BI scan time. This parameter goes from 0 to 10. 0 turns the process off, but the 0 to 10 will indicate how frequently this process scans, looking to basically that it's garbage collecting here, how frequently it scans to be able to process the ones that are already committed and recyclable. This parameter can be tuned online using Promon and the dbparan VST. What this does is it reduces unnecessary database storage usage and avoids database performance slowdown caused by user mistakes. As we have studied using this process and the parameter, here are some of our findings. One is that the BI space management can be significantly reduced or eliminate abnormal BI growth caused by user applications. It's basically going to smooth things out. We saw approximately 9% performance gain in the case of long idle transactions. We also did not see noticeable resource overhead from the BI space management process. The smaller BI scan time will lead to quicker response to your BI growth, and it has little more overhead compared to the larger BI scan time. The smaller and larger is actually a frequency, so the smaller number is going to be a more frequent use. Our recommendation is to set the -BI scan time default to 10 seconds. And then if you notice that you're having BI growth, you can tune it down online when you're still seeing that growth. Okay, our next area, we're moving to indexing. What we're always looking for with indexing is faster and more flexibility because our goal is to support scalability with the index operations. Our first area that we've looked at is multi-threading index check. Index check is one of the two most commonly used database health check tools. We use it frequently to identify problems and to ensure database integrity. It's particularly important in a DB down situation when you're scanning for corruption. In such situations, index checking needs to be done in a reasonable amount of time to be able to determine your recovery strategy and get your database back online. The problem with index check, especially with the larger databases, is that there's just so much there to check. It could take a very long time to execute. And we have heard anecdotally from customers that on a terabyte-sized database, index check can run for more than a month. So our solution here was to implement threading techniques to improve parallel processing in the index check operation. This will help make maintenance easier to perform, help users to respond to emergencies, and also encourage using it preventively against future emergencies. Our threading ability on index check is available for index check options 2, 3, and 4, which are the most frequently used options. The threading model will vary with the processing algorithm of each of these options. And we've also found that the locking behavior, either -no lock or table locks, will follow that pretty much consistently with the existing non-threaded index check. So what we're really saying here is that threading index check does not interfere with the locking behavior. Here's a summary of the command line. We've added the -thread and the -thread num. So -thread basically turns threading on for index check. As a matter of fact, we've defaulted it to on. And the thread num is going to lets you specify how many threads you want to use. The default is 6. However, if you have fewer than 6 CPUs available, it will go to a smaller number because we can't have the threads exceed the number of CPUs. DBAs can adjust the thread num to be whatever works for them. We do want to note that the threads are not spawned in the case that you've selected a word index identified as what you want to thread with, or for small table objects, because we have found with the smaller objects, there really isn't a benefit to the threading. This is the thread model for options 3 and 4, which are dealing with validating index keys. So it's a key entry centric model. And basically, we're showing how the index is split amongst the threads. So in this case, we used a thread num of 4. Based on the values of the root block entries, the non-leaf blocks will be assigned to different threads, which will then be validated by the utility in parallel. Our other model for option 2, which validates the keys for each record, so it's starting with the records, so it's a record-centric thread model, is that each thread will read the next data block in an area, and then it extracts the next record from the data block, and it builds the index keys. So then the processing on that is that it searches the index trees with those keys. Again, we're looking that everything correlates as it should and is present as it should be. Okay, that takes care of threading index check. I'm going to move on to index compact. This is about the delete chain. The index entry deletion for unique indexes is a special case because when those entries they're not actually removed, they are modified to become delete holders that remain in the trees. When a block is full of delete holders, it's put on the delete chain of the index. When a table is deleted, the whole index might be put on an index delete chain. The problem is that when customers do mass purge operations, these will lead to dead branches that are never touched by index operations. When an entire table has been deleted, millions of branches may be left empty. This can result in more blocks on the delete chain than the remaining blocks in use. And queries scanning over unused index blocks will adversely impact the OLTP performance. The mechanism we use to clean them up is index compact. Currently, the cleanup of the unused blocks on the index delete chain is embedded in some operations like index build and record create and update. So we chip away at it over time. During that time, when it's just being reduced a small piece at a time, you're still scanning that index delete chain as part of processing. So customers have requested the ability to quickly remove their unused index blocks because they know they have added these as a result of a mass delete activity. The index compact utility operates in 3 phases, and it's phase 1 that if the index is a unique index, the delete chain is scanned and the index blocks are cleaned up. So what we have done is added the option to index compact, the option unused blocks, which will only clean up the unused index blocks by executing only phase 1 of index compact. That way index compact doesn't have to proceed through phases 2 and 3, which are much more expensive because they involve BI overhead and walking the B tree. Next, we'll look at a couple of improvements that we put on to index activate. This first one, problem 1, also started by an entry in our online community. He says, I'm having trouble with a table that has a total of about 100 million rows. Have I encountered a limit? And what we found is that we rarely need the underscore file table reads for every single record that index activate touches. There was several comments on this issue. basically where customers started talking about, whose table is bigger, what OS are they on. One noted that adding an index to a 100 million row table is actually adding 100 million pieces of data. And then they got to what is the activity of index activate. And then when someone posted that the underscore file table is read for every single record that index activate is touching, that got our attention. So our solution was to implement a cache. And if the index activate does not include a schema change, there is now only one underscore file record read during the building phase of index activate, as opposed to hundreds. Our second problem was discovered during an additional code review. That index activate is also wasteful when inserting index entries. It turns out that for every record, it was verifying that the entry does not exist in the target index before it inserts it. And their solution to that was simply to take out that verification because the index manager already handles duplicate key entries. So we've gotten significant performance improvement with index activate. Well, we're coming to the end of my presentation. In summary, we looked at backup and restore, space management, and indexing, and all of the additional options that reflect additional functionality that we've put into 12.8, the LTS. So I want to thank you for joining me to look over these features. And I'd say, Jess, I think we're ready for questions.
Great. Thank you, Marie. So now we'll turn over to the live Q&A session. And as a reminder, if you have any questions, please put those in the questions panel. I will do my best to get through all the questions we have in the time left, but if I am not able to answer some of your questions, we will be sure to follow up after the webinar. So Marie, are you ready?
I am.
Great. So the first question is for Pro Backup and Pro Rest. What are the default values of -thread?
Oh, I noticed that when that question came in that I neglected to put those there, though I did later for index check. So they're basically the same set of values. The threading, I believe, for 12.8 for backup and restore is defaulted off, but then your thread num values are also going to be tied to the number of CPUs you have. And I believe that maxes out at 6 default value. I believe we default at 6 unless you have less than 6.
Okay. And someone wants to know, are all the mentioned features available in Workgroup?
So I did a quick review through the slides after this question was posted because I couldn't recall that any that differentiated between enterprise and workgroup. So in general, where these would differ is between type 1 and type 2 type storage, and also online versus offline. But they are available on all enterprise workgroup and personal.
Okay. The next question is table reorg available on 12.2?
Unfortunately, no. Table reorg was first introduced in 12.3 and then expanded a couple of times in subsequent innovation releases. So to get the full table reorg functionality, you have to go to 12.8.
Okay. The next question has to do with backup. So this person wants to know, does this compress a TDE-enabled database?
It does not compress the encrypted data. What I don't know is, does it operate at a database level or does it operate at the individual table or record level to determine whether to compress? So I'll have to get back to you with more information on that.
Okay. The next question is, I saw some database items in the What's New in 12.8 webinar that were not mentioned here. How do I learn more about those?
So unfortunately, there were so many things that we did between 12.3 up to 12.8 that there just isn't enough time. So what I recommend you do is you go to the Progress website into the 12.8 area, and in the docs area, you will find a What's New in OpenEdge 12.8 document. And when you go to download that document, there's the opportunity to be able to get everything actually from 12.0 to 12.8 in a single document. And I recommend that you do that. You download, basically, it's called the entire publication. And then you can use your search functionality in Acrobat to be able to find the things that you're looking for. The What's New documents have small blurbs identifying the features and when they were enhanced. And this document will also include links right into the documentation for the feature, so you can do a deep dive with it right then.
Okay. The next is, there is a lot of good things in here to reduce performance, times, or size, but no numbers. What can we expect for improvement?
Well, this was a challenge. Every single one of these that were intended to be performance improvements definitely were measured as part of the development completion. Most of that testing, well, actually all of that testing, was on a specific improvement. We also had some measurements taken where we combined options to see how the improvement would also combine. The thing is that, as frequently happens between what we develop and what we test, and then what you have happening in real time for your database size, configuration, etc., it turns into your mileage may vary. So it's very difficult for us to publish numbers that you can really take home and say, this is exactly how it's going to improve my operation. However, I can guarantee you, especially with the threading stuff, there were several things in here that reduced the operations in our testing by a third to a half. Some of it was just amazing. We were very excited.
Great. So the next question is, I liked the focus of this webinar on the database administrator or administration. Are there any other webinars that are like this?
There's actually a trio of them that we were doing. This was focused on the DBAs. Last week, we had one that was focused on development. And next week, we're going to have one that's focused on business users. The good news is what you were getting last week, today, and next week. Those are the live Q&A sessions, but these are being recorded. And so you'll have the opportunity to go get them on our website, again, under OpenEdge, and look for resources, look for webinars, and they'll all be available on demand so that you can listen to them when you're ready.
Okay, great. And this is the last question that we have time for today, and it is, why did you do that return space to the OS as a 3-step process instead of a single command?
This was one we had a lot of discussion on. Our overall goal was to be able to return space to the operating system while the database was online. But as we looked at what needed to happen to be able to do that, we realized that it was better implemented. The steps on the way to that were better implemented as an addition to already existing commands for the most part, but also that we have learned over time that if we do something that's like a 3-step process, if we do it as all one process for you, often you come back and you ask us to break it up. I think we had one of the items with the delete chain on the index here, where you come back and ask us to break that out as a separate operation because it's useful to you that way. So we decided to build that flexibility in at the first attempt here and offer it to you as it's a 3-step process, but you can do any of those processes at your own opportunity. You don't have to commit to the whole 3 steps all at one time.
Great. All right, Marie, so that's all we have time for today. That was a great presentation. We still do have a couple questions in the queue. So if we didn't get to them today, apologies, but we will reach out after this call and follow up in the next couple of days. If you didn't get a chance to ask a question, please respond to the email that will have ways to contact us, or just reach out via the ideas portal or the CVP and we'll be able to get to you over there. And thank you to everyone who attended today's webinar. And again, thank you to Marie, and have a great rest of your day.